How's that for a slide? Took a long time. Bicycle factory. Let's think about a bicycle factory in very simplistic terms. What do you need to make a bicycle? You need wheels. How many wheels do you need? 2. Those are my bicycle wheels. What else do you need? Maybe a frame. This is harder. There's the handlebars and there's the forks. Yeah, and there's a seat. Do you need pedals? Yeah. Let's just keep it simple. We'll say that the pedals are on the frame. So we put those things together and we get how many bicycles? 1. I should have practiced this. As you can tell, not an artist by any stretch of the imagination, but I can play Pictionary. That does make you think about a bicycle, right? Even though it may not actually look like a bicycle. So let's abandon the horrible drawings and use words. 2 wheels plus 1 frame makes 1 bicycle. I'm going to call it bike because there's fewer letters. So we're going into the bicycle factory today. We're going to make some bicycles. And we've got 50 wheels. And we've got 75 frames. How many bicycles can we make? 25. How did you do that? That's right. It's because we know how to think about bicycles, right? And you're thinking, well, 50 wheels, I need 2 for each bicycle. So I can only make 25 bicycles out of that many wheels. I have 75 frames, but I can't use them all because I don't have enough wheels. And who's going to buy a bicycle without any wheels? That's no fun, right? This is the limiting reactant concept. Up until now, we haven't discussed the amounts of both reactants. We've just looked at one and assumed that there's plenty of the other. But in real life, this is more likely to happen, where we have one of these things that limits how much we can make. The wheels are going to limit the production of bicycles today because we're going to run out of wheels. And so we did this in our heads, which is great for bicycles, but when I talk about iron sulfide and sulfur dioxide, doing it in your head doesn't work so well, right? So let's look at the process we went through. What we did in our heads was we mentally figured out how many bikes for that many wheels. So I get 1 bike for every 2 wheels. This cancels out. I get 50 divided by 2, 25 bikes. The frames, I get 1 bike for each frame. Frame cancels out. I could make 75 bikes. Now with bicycles, we look at that and say we can only make 25. When it gets to chemicals, people do crazy things like adding 25 and 75 and say we could make 100 bicycles. No, you can't. Because as we're going along making bicycles, 15, 20, when we get to 25 bicycles, we run out of wheels. And the reaction, the production of bicycles stops. When we run out of one of the reactants, we can't make any more product. Okay, so this is the idea of the limiting reactant. So let's look at iron and sulfur. So if we heat a mixture of iron powder and sulfur, we produce iron sulfide. Here's a picture of that happening in a test tube. So let's look at scenario A, where we have 1, 2, 3 iron atoms and we have 4 sulfur atoms. We don't have an equal number. It's really hard to get an equal number of iron and sulfur atoms so that everything can work out perfectly? Well, what can happen? Well, let's write on this, maybe, I don't know, red. So we could take these two and make one iron sulfide, and we could take maybe this one and that one and make this guy. It's not real clear. Those are right next to each other, so they're reacted together. It's not real obvious. And then I could put these two together and make this one. But what about this guy? He's left over. Like, what happens to those extra frames in the bicycle factory? They sit there, right? They sit there until we get another shipment of wheels, and then we can make more bicycles. This sulfur atom is just going to sit there and not do anything. And when we look at the reaction mixture afterwards, there's going to be some sulfur just sitting there. Which of these, the iron or the sulfur, is limiting how much product we can make? The iron. All of the iron got used up. We had extra sulfur. So the iron is the limiting reactant in this illustration. Let's look at this one down here. Now I've got 4 of the iron atoms and 3 of the sulfur. So I could put these two together and get this one, and I could put these two together and get that one, and these two together and get another one. And what about this guy? Left over. Doesn't react. So in this situation, sulfur is the limiting reactant. The limiting reactant gets all used up. So what we call the limiting reactant is the one that limits the amount of product. It's the reactant that limits production, the limiting reactant. So instead of drawing pictures, let's think about moles. Suppose we heated 2.5 moles of iron and 3 moles of sulfur. How many moles of product would we get? Well, here's a little table from your book. Before the reaction, we're starting with 2.5 moles of iron and 3 moles of sulfur, and no product. Well, how many moles of product will 2.5 moles of iron make? All of these coefficients are 1s. 1 mole of this will make 1 mole of that. So 2.5 moles of that will react to make 2.5 moles of this. That will use up 2.5 moles of the sulfur, but there's some left over. And so at the end, we're going to have half a mole of sulfur left and 2.5 moles of iron sulfide. That doesn't work really very well with how I think about things. I would rather, oh, it's still red, that's okay. I would rather think about it this way. I'm going to take that number of moles of iron, and I know that I make 1 mole of iron sulfide for every 1 mole of iron. And so I'm going to make 2.5 moles of iron sulfide. And then I'm going to look at the other reactant, the 3 moles of sulfur. Just like I did with the bicycles. So 1 mole of FeS to 1 mole of sulfur. And so that could make 3.00 moles of FeS. I forgot the mole. So can I make 5.5 moles of FeS? No, just like I can't make 100 bicycles if I only have 50 wheels. What I'm doing is I'm taking the one reactant and figuring out how much product could I make, assuming I have enough of everything else. And then I take the other reactant, and also figure out how much I could make. The amount I can actually make is the smallest one, right? I just look at these two numbers and I ask myself, which one is smaller? Well, 2.5 is smaller than 3. Because when we get to 2.5 moles of iron sulfide produced, we ran out of iron. It's all used up. We can't make any more. Yeah, if we had more iron, we could make 3 moles of iron sulfide, but we don't. And so we say that the iron is the limiting reactant. It limits production. 5 mole sample of iron 3 oxide heated with 5 moles of aluminum metal. That gets converted to molten iron. Identify the limiting reactant and calculate the moles of iron produced given the unbalanced equation, right? Okay, balanced equation. I don't know about you, I'm tired of balancing equations. Gonna do it anyway. So 2 aluminums. So I need to put a 2 here. And I have 2 irons, and I only have 1 over here. And then there's 3 oxygens and 3 oxygens. Phew, that worked out. Okay, there we go. So this says I have 5 moles of iron oxide. So I'm going to write that here. 5.00 moles. And it also says I have 5 moles of aluminum. This is different from the other problems we were doing, right? The other problems gave us one number and asked us to find something. And then they're saying calculate the moles of iron. So question mark moles. When you see 2 quantities, that means it's a limiting reactant problem. And what we're going to do is we're going to do 2 calculations, just like I did with the bicycle factory. We're going to take one reactant, find the amount of product. We're going to take the other reactant and find the amount of product. And the smaller is the actual amount of product. The one that gives the smaller amount is the limiting reactant. So 5 moles of Fe2O3. I want to figure out how many moles of Fe I can make. I can make 2 moles of Fe for every 1 mole of the iron oxide. That's not a 2. That's a 2. So if I was able to use all the iron up, I could make, all the iron oxide, I could make 10 moles, right? If I have 5 moles of aluminum and can use all of that up, now I've got moles of aluminum on the bottom. See, I wanted these to cancel out, and I want these to cancel out. There's still a 2 in front of Fe. It's funny how that works. There's also a 2 in front of aluminum. So 5 times 2 divided by 2 is still 5. How much iron can I make? 5, the smaller one. Because when I get to 5 moles of iron, I run out of something. What do I run out of? Aluminum. So you identify the smaller product, and then you go back to see what started that one, aluminum. This question is saying identify the limiting reactant and calculate the moles of iron. If I just wrote this out, have I answered the questions? No. This is all the work necessary. Now just finish it. So this is the amount of product. In my class, putting a box around it, that shows me that you chose that one, right? And then the limiting reactant, we get tired of writing that, so we call it LR. Limiting reactant is aluminum. That would be fine. I am not huge on beautiful complete sentences. I like beautiful complete sentences, but the point of this is doing a calculation.